Welcome, and thanks for taking the time to understand more about the features and specification of the ZestSC1 from Orange Tree Technologies. Supply with software support, libraries, logic cores and design examples, the ZestSC1 is an FPGA plus USB development and production board that connects to a host PC through high-speed USB. In terms of performance, the ZestSC1 is capable of saturating the 480 megabits a second USB 2.0 bus and delivers a sustained 38 megabytes a second data rate. The ZestSC1 features a number of main components, and if we zoom in we should get a closer view of these. There is a choice of Xilinx Spartan 3 FPGAs. Here, either the 3S4000 with 4000 gates or the 3S1000 with 1 million gates. And the FPGA can be configured either from the USB here or via a JTAG cable to these pins here. The USB microcontroller is the Easy USB FX2 device from Cyprus, and there is also up to 8 megabytes of SRAM on the board. The SRAM is pipelined ZBT, zero bus turnaround SRAM for no wait states between the writes and reads. The SC1 is used across an array of end markets such as semiconductor prototyping and test, industrial control and factory automation, communications, defence and aerospace, with typical applications including laser marking system controllers and DAC for a wide variety of applications from radar systems through environmental monitoring equipment and RF circuit development. The compelling value proposition for coupling USB 2.0 with FPGA technology is to provide the designer with lots of flexible I/O, field upgradability of the hardware through FPGA reconfiguration, and the opportunity for local to the end system parallel processing of data inside the FPGA. For I/O, the ZestSC1 is fitted with a 64-pin header for ribbon cable or to connect to a daughter card. 49 pins are connected to the FPGA for user I/O, 13 pins are connected to ground, 1 pin is connected to 5 volts and 1 pin is connected to 3.3 volts. 13 LEDs are provided on the board. 8, you can see here, are connected to the I/O pins. We have 4 LEDs for power indication here and 1 LED for the FPGA done signal. With up to 95% efficiency, the onboard power supply unit enables the board to be powered entirely from the USB port from here. If more than 2.5 watts is required, it can be powered from a wall adapter, or if the board is fitted inside a PC, it can be powered directly from the hard disk drive via this connector here. We provide 3 interfaces between the USB chip and the FPGA, and all are accessible using the host library that is supplied with the ZestSC1. Streaming, data streaming at the maximum USB bandwidth, registers, control and status registers in the FPGA application, and signalling, single bit interrupt and flags. The FPGA clocks are fixed at 48 MHz for the streaming interface between USB and FPGA, and for the microcontroller registers between USB and FPGA. To provide an out-of-the-box experience, the ZestSC1 is supplied with a host library and drivers for configuring the FPGA and communicating with the FPGA that run on Windows and Linux. The FPGA can be programmed using free-of-charge ISE Webpack tools from Xilinx, and Orange Tree also provides IP in the form of optimized SRAM and USB interface cores. To accelerate design productivity, design examples are included that consist of a host program and a VHDL or Verilog project. Model sim test benches to illustrate how the various interfaces can be simulated before implementation, how to configure the FPGA from a bit file generated by the Xilinx place and route tools, how to use the high-speed streaming interface on the board by measuring data transfer rate between the FPGA and host in either direction, how to use the low-speed control interface on the board, and how to use the SRAM. The board itself, as you can see, is designed into a small form factor, measuring 74mm by 122mm, making it ideal for OEM or desktop use. So if you'd like more information about the ZestSC1 or the technology behind FPGA plus USB host system interconnect, please visit orangetreetech.com. And also look out for more video sessions and tutorials where we run through design examples and we look more into the Zest series of FPGA and USB interconnect solutions.